Okay, we are going to continue with solving of trigonometric equations. Okay, so whenever you see, as I mentioned, trigonometry ratios like sine, cosine, tangent, cosecant, whatever, right? Then there's an equation here. Then they ask you to solve. You must remember to use the add math. Okay, very important. You use add math. All right. Um, Let's take a look at this question. Now, for today's lesson, I'm just doing 3 new questions. Then later, right, I'll modify the questions in paper 1 to show you another type of questions that you'll be getting. Okay? It's very simple one, don't worry, okay? Let's look at this first. Solve for 0 to 720. Wow, how come now it's from 0 to 720. Last time was like normally from 0 degrees to 360, right? Or from 0 degrees to sorry, from 0 to 2 pi, right? But just let me tell you, they can give you any domain they want. They can even say 0 to 180. Then you just stick to the first 2 quadrant. Okay, so now let's do this. How to do this? Okay, you look trigo equation, right? So you think of add math. The first E, the E, right, stands for equivalent form. So you must express this somehow in terms of sine cosine or tangent. Okay? Then you will tell me, oh yeah, it's already sine and cosine. But it's not really in the form that we want. We want this equal to a number, this equal to a number, or this equals to a number. Either one of these. Now, it's like there's some sign here, some cosine here, some sine here, some cosine here, right? So what do? This is where whatever you learn in lower sec comes in useful. When you have a bracket here, you open up. Why open up? Because now with the brackets, right, they are all trapped. Okay? So by opening up the brackets, which is this, you are releasing them from their prison. You release them from their prison, okay? Now that they are free to move, you see, once there's no bracket, they are free to move, right? You can group all the sine people together. So you can ask this person, come here, sine. All the sine people gather here, all the cosine people gather here. Alright? Then you can simplify it to be this. Then you ask me, is that what we want already? Not exactly, because we want sine of something equals to a number, either this to a number to a number. You see, now it's not equals to a number yet. So how? Then you may do this. So you may think, oh, maybe I throw this here minus sine x minus 5 cos x equals 0. But again, based on our add math, no, this is not what we want. We want sine of something equals to a number. Alone, alone. Sine of something alone equals to a number. This is minus sine plus this is minus sine minus 5 cos x. So it's not. So what can we do? Then that is where our knowledge of all these identities will come in very useful. Okay? So we do have sine and cosine, right? Sine and cosine here. So can you see that if I were to divide both sides by cosine, I will get tangent. See? I divide both sides by cosine. That means this, I divide by cosine x. Alright, left hand side, I also divide by cosine x. Whatever you do on the left, do on the right, you will get this. Okay? And is this what we want? Not exactly. Okay? We only want tangent, which is sine over cosine. We don't want the minus, so you multiply by minus both sides, you get this. And finally, we have the E done. Sorry, the add math, the E done already. Okay, so you see, all this while, when we were in class doing the simple basic questions, right? The E is like, already given to us, right? But now, you yourself, because now you're advanced stage already, have to manipulate the equation until you get your own equivalent form. Okay, so this is how you do it, huh? Okay, now after this, what do you do? Using our add mat, okay, we've done this already. Now is to check the domain. The domain, this first domain, there are two domains. This first domain, right, you just check that the argument here, the thing that is immediately written after the tangent or the sine or the cosine, right, is what we call the argument. Okay, it's the thing that we are talking about. Okay, so this argument, is it the same as this given domain here? If it is, you don't have to do anything. Okay, you move on. You just take note that, oh, it's in degree because there's a degree symbol there. So next step, add mat, ED done already. M is the mode. We say, and we mentioned just now, it is in degree. So change your calculator mode to degree now. Okay, next is A. The first A is the L, then the second A is the S, right? Wait, the first A is the L, second A is the S. So you do the alpha first, which is the acute angle. Alright, then after that you determine which quadrant it is in. Okay, that's what we are going to do now. Remember, when you find your alpha, you do not put the minus here. Okay, because we want an acute angle, so we only take this number here. When you take this number here, you will get an acute value, acute angle here. You don't believe me, you go put a minus here, right? You will not get this acute angle. It will be greater than 90 degrees. Okay, now that we have found the alpha, very good. We have to now determine, I do here as a reference for you. We've done this, we've done the domain. That means check that this is this. Okay, now mode already in degree, alpha already done. The ASTC, that is next. Okay, ASTC, you draw this and you ask yourself, do you want tangent to be negative or positive? The question, based on your manipulation, right, wants tangent to be negative. Okay, so you take a look at your ASTC. Tangent is negative here and here, which means that your angle is going to be in this quadrant. Okay, and of course you know that the butterfly, this is your 78.690, correct? Okay, and again you want this quadrant, using vertically opposite, right? This is your 78.690. Okay, so your x is equals to 180. If it's in radian, then it's pi minus this angle. That's your first answer. Done already. This answer is this answer. Second one is all the way here, right? All the way here. Oh, sorry, overshot here. Okay, so it's, don't you agree, it's 360 minus this angle, so you get this one. Okay, and thirdly, oh, why is there a thirdly? Because, ladies and gentlemen, if you were to look at the last D, it is also domain. Okay, and this domain is this final check. My x must be between 0 and 720 degrees. So, this is only 100 plus, this is only 281. Now, this is something new. This is something new, okay? Very new. Don't you agree that this first angle is here? 101.3. And in this quadrant, tangent is negative. Yes, right, tangent is negative, correct? You don't believe, you go and press tangent 101.3, you get around -5, okay? Don't you agree that if I were to add 360 degrees, that means I make this angle go one more round, 360 degrees. Isn't this one whole round of 360 degrees? If I add 360 degrees, it will still, you see, you add 360 degrees here, 180 plus 360 degrees is 540 but you can straight away add to here. You add 360 degrees, you will get this. Alright, this angle, alright, amazingly, when at first it's here, right? This is 101.3, then you add 360 degrees, right? Oh, it ends up, now you are like in the second cycle. It's like round, go, merry-go-round, 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 right? You are now in the second cycle, but when you're in the second cycle, when you come to this quadrant, the S quadrant, right? Oh, tangent is still negative. Okay? So you don't believe me, you go and press 4, 6. Is this 1 or 7? 4, 6, 1, 0.3. You will also end up roughly minus 5. Okay? So that's the powerful thing about this ASTC. Very, very, very powerful. Okay? Alright, so we are actually just going, this will give me this quadrant, and in this quadrant, tangent is negative. Minus 5 lah, if I go one more round, how come I can go one more round? Because the range or the domain given to us is until 720. There, this is within 720, so can. Okay, very good. This is the new thing for today, okay? Then now, if this angle can go one more round, can this angle go one more round? You add 360 degrees. Is it still within this this range, this domain? Yes. Okay. So you see, in my working, I added 360 to this is this one. The rest are all the same. Can you see? I add 360 to this is 720 minus this, right? 720 minus this. So the rest are all the same. Okay. So that is the these are the 4 answers for this particular question. Then you ask me, can I 4 answers? Yeah, there are 4 possible answers. You don't believe me? You press tangent of this, tangent of this, tangent of this, tangent of this, you will get roughly this minus 5. Okay? Or even better, you sub here into the original equation, 101.3, sub here, sub here, sub here, sub here, right? You will find that this value on the left is equal to this value on the right. That is the whole idea of solving. Alright? I hope you are clear. So this is a new example, and we use this new example to learn something new. Okay? Now, I'm going to go to another example. The other example is here. Okay, this particular example, alright? Now, this question is still something like episode 1. Everything is still within 0 to 2 pi. That means 0 to 360. That means we are in the first round only. We didn't go to the second round. Okay? Never mind. I need to expose you to more types of questions. Alright? As we move on in the episode 2, 3, 4, we will go more advanced. Alright? Okay. Again, take a look at this. Solve. Solve what? Trigo ratios, and then with equations. So it's actually solving trigo equations. When you solve trigo equations, you must think of, where is that piece of paper? Anybody can remember what I want you to think of? Add math. Okay? Add math. This add math will really help you. You will appreciate it next time. Okay? All your friends will be making careless mistakes because they never use add math. You use add math, you win them. Okay? Now, is it number 1 in the equivalent form? Is it like in the equivalent form, cos alone, some number, sine alone, some number, or tangent alone, some number? No. Sadly, no. Okay. So, no choice. We have to think how to move from here. And normally, as I mentioned to you in class, if you can break it down into the basic cells like your biology, cosine is a so-called a basic cell. Cotangent, do you remember cotangent? Cotangent, if you break it up, cotangent is actually the inverse or the reciprocal of this. Not inverse, sorry. This one is a reciprocal. So it's cosine over sine. Another way to write it is 1 over tangent. But we don't want to write 1 over tangent here. We don't want. Because 1 over tangent, then it's still not the same as this one. Okay? So I want to write something similar. So I write cosine over sine. You see? Like that. Then you tell me, oh, also not the same one. Not like that, Yeah, not like that. Okay, so we have to do something more. What's that something more? Oh, you notice that this fella has no fraction. Actually, it has 1 now, but 1 is okay. But this fella has a fraction. I mean, the denominator has there's a denominator of sine theta here. So what can you do? You multiply by sine, multiply by sine, multiply by sine to get rid of the denominator. Okay? Then you ask me, this is still not equivalent form. No, nothing like this at all. Wait, nothing like this at all. Yeah, you're right. So what else can we do? That's why you learned last time in Sec 2 to factorize. Okay? Now you see all your Sec 2 work coming to life. Okay? Yes, finally found meaning. Okay? You can take this out. Alright? Then you say, take this out for what? Oh, once you've taken this out, right? This times this equals to 0, right? Meaning either this equals 0 or this equals 0. It's something like your this you factorize, right? Then either this equals 0 or this equals 0. Don't you agree? So that is what you are applying here. Okay, so either this equals 0, which I've written here, or this equals 0, which I've written here. Okay, then now is this in terms of my AddMath equivalent form? So sad, we are still at this stage. We haven't even done the E, we are still at the E. Okay, the E sometimes is very long. Okay, and it tests you on all the concept that you have learned in lower sec. Not that it's testing you on the lower sec concept but actually more like the lower sec concepts are taught to you so that you can do all this to solve the question. You understand? Okay, so cosine theta equals 0. How to solve? This kind, right? I would not want you to press calculator. Then you say, why cannot press calculator? Because I want you to practice your curve sketching. Okay, so cosine graph, do you remember cosine graph is quarter of an egg, quarter of an egg, quarter of an egg, quarter of an egg. Okay, and because this is 1, so this is greatest value 1 minus 1. That means the amplitude is 1. Okay, now may I ask you, what is the angle for one full cycle? Cosine, right, is 360, one full cycle, correct? Okay, halfway is 180. Alright, you want 0. Must be 90. And then 9, 18, 27. 27, 270. That's why this answer is this. Okay, sorry, I worked in angle. Alright, it should be in terms of pi lah. Okay, sorry, I missed out. That is the result of not using AddMath. Okay, I wasn't referring to AddMath. So these are the few. So pi over 2 is one of the answer. 3 pi over 2 is the other answer. That's it. You see, does this fall within your domain or your range? Yes, it does. Okay, now let's look at the other side. Now, only when cosine theta equals 0 lah, 1 lah, minus 1 lah, then I will use this method. Okay, because if you were to press calculator, you'll find that it's not as easy as you think. Okay, we'll discuss in class next time. Now, either this equals 0 or this equals 0, right? We found this already. Now we're going to find this. Again, make sine theta the subject. That is part of the AddMath, the E equivalent form. Okay, now that we have this, what do you think is next? Check the domain. Just now we checked already. It's between 0 to 2 pi. Okay, 0 to 2 pi. And this, sorry, this should be theta, right? Theta, okay, theta here, alright? Theta here. And now that we know the theta here is the same as the theta here, no need to do anything, okay? No need to do anything. Maybe next episode then we have to do something. Today I don't think I can finish. Now, after you have had your equivalent form, the domain, done already. You just double check that it's same. Same. Don't need to do anything. Now check the mode. What mode must it be in? Radian. Okay. Now the A is alpha. Find the alpha, then find the ASTC. Okay. So alpha, remember, do not put in the minus. Okay. You put in the minus, you will not get an acute angle. Okay, so don't put in the minus, you throw in this, and then you will get this in radian mode. Now, after that, you have to determine which quadrant it is in. Is it A or S or T or C? We want sign to be negative. Sign positive, positive, negative, negative. So it's this quadrant or this quadrant, okay? And because of the domain given to you, it is only one full cycle here of possible values. You don't go another round or another round. You don't go second round. Okay, so this is one possible value. You want this, okay? To find this, remember it is 180 plus this value. This value is your 0.72973. Okay, that's what I have here. Done. Then you can get the answer 3SF. Okay, next we want here. Remember your butterfly? That means this is your 0.72973. Now isn't this whole angle 2 pi? So you take 2 pi minus this. Finish. That's all. Alright, very straightforward, very easy. Okay. Due to time constraint, I may just do one last question. I told you I'm going to do something new. I actually did a little bit, but not the whole thing. Maybe episode 3 tomorrow, then I go through so that you don't feel that it's too overwhelming. Okay, this will be the last question for the day. Okay, solve this. Again, it's trigo ratio equation, so you use add math. Alright, check. Is this in the equivalent form? No, it's not. Because you have power 4, power 2 and all that. Now, why in the world is there power 4? Whenever you see power 4, power 2, you later probably have to let m equals to sine square. You know? Yeah, something like that. Okay, but now you see, we have a big problem, and the big problem is that we have cos and we have sine. We don't want. Because if we have cos power 4 x and 5 sine square x, right? We cannot express it in the form that we have, our very first episode, like that. Then we can do quadratic. Cannot, right? Cannot, because one of them is in cosine, the other one is in sine. Cannot. You have to either all cosine or all sine, then you can do the quadratic formula. Okay, so what I'm going to do is I'm going to change one of them. Alright, and the easiest to change is not this, but this. Why? Because if you were to look at your identities, by the way, this can be found in the formula sheet. Okay, on the second page of your exam booklet, these cannot be found. You must memorize these. Okay, this one, if you are lazy, you don't want to memorize, there is still hope because it's in the formula sheet on the second page, alright, of your formula of your exam booklet. But I would strongly recommend everybody to memorize during these holidays. So if I were to refer to this list, I will see that if I don't want the sine square, I want to change it to cosine square, then this is the identity I need to use. Okay, you can call it a formula also can. So if I only want this, don't you agree that I can throw this over the other side? Minus cosine square a both sides. So this will be minus, 1 minus cosine square x. Don't write a, this argument is x, you write x. Okay, now we are happy. You know why we are happy? Because now everybody is in cosine. Everybody is in cosine. So now we are happy. It's like everybody is from 3 innovation. We are happy. If somebody from 3 honesty, then there's a stranger there. Okay, now you open up the bracket. then you write it in the form, you know, like your quadratic formula form. Then you say, no, this is not quadratic, this is power 4. Yeah, we can change it. We can change it into quadratic. You think of this, right, as 2 cosine square x. Square, then you go and square again, right, is power 4. So this fella is like your x, the big X, okay? And then this is your x, the big X, minus 3 equals 0. Okay, those who don't understand this, you PM me, okay? I'll explain to you. I don't want you to waste time saying let m equal whatever. No need lah, no need. We are advanced. We are very, very intelligent people. We don't waste time, Okay, so now can you see that this is my A? It's something like ax squared plus bx plus c. Okay, this is your c. So when we put it inside here, minus b plus minus b square minus 4ac, ac all over 2a, right? Okay, now again you press your calculator, you get this. And I hope you know why we reject this. Those who have forgotten, cosine square, right? You square root, you cannot accept. You cannot square root a negative number. Alright? Which means that very good, we only have one thing to work with. Are we now done with the ADMAT, the E, the equivalent form? Is it equivalent form already? No, not yet. Because equivalent form means there's no square whatever. Now we have a square here. We need to get rid of this square. How do we get rid of this square? Square root both sides. That's what you do. Okay? Yeah. Then right now, right, what do we do? Very simple. What we do now is ADMAT, right? ED, domain, check. Is this argument the same as this domain argument? If they are the same, don't need to do anything, okay? Next lesson, then I tell you the cases where we need to do something. Okay, next step, mode. Degree, right? So change to degree mode. Okay, then you alpha. Okay, I will now write the ADMAT here. In the exam, you do this, okay? In the exam, hey, ladies and gentlemen, there won't be this paper for you, you know? And then I won't be flashing this in the hall for you also. Cannot, Okay, you write by the side. As you do this, tick. As you do this, tick. Mode done already? Done. Change to degree mode already, you tick. Okay? Alpha, right? Alpha done already? Alpha. Remember, ignore the plus and minus. You only cosine inverse this thing, and you'll find that, oh, it's 45 degrees. Very nice number. Done. Okay? Now, what does this A stand for? ASTC. How come I never draw ASTC? Okay, here. You need to draw ASTC. So, ASTC. Now, oh, I know why I didn't draw already, because it's plus minus. Plus minus means everything also is okay, whether it's positive or negative or accept. You see, all four quadrant also accept. That's why the answer is like that. Okay, so take a look. If you have any questions, please ask me. We'll end here today. Today is a short one, just to get you very sure how to use ADMAT. Okay, ADMAT. Alright, we are the only ones in the world who knows ADMAT. Okay, see you tomorrow.